Yeah, yes, sir.
Yeah.
Screen is visible, sir. So for this eighth session, I welcome you, sir, once again for the session. You can carry out and informate us with your technical competence.
Yeah.
Thank you, sir.
Okay. Good morning, everyone, and it's a pleasure to take the next section today. Hope the yesterday session you people got some basic understanding of IoT and all the architecture of IoT, and then how the cloud storage is used to store that massive amount of IoT data. And throughout this session, you are deeper dive into the various components of IoT. So today, our focus is how this IoT used in the industrial application. So myself, Senthil Kumar, I run a company called JioVio Healthcare. It's a medtech startup company. So today we are going to discuss this four main topic. What is this industrial Internet of Things mean? And what is this industry 4.0 mean? There's a new terminology we're calling it like industry 4.0. So we understand what it mean. What is that industry 3.0, 2.0, 1.0? We understand that basics. And then we understand various use cases of industrial IoT. And then the available platform. So yesterday, the platform wise, we have done a deeper dive into the Amazon platform. We understand the whole architecture of the cloud storage and how the data flows in the sensors, gateway, and cloud platform and the user application. So today, the same thing we are discussing about IIoT platform. So IIoT platform is like we have a company like Snyder, GE, Siemens. These are the leaders in industrial automations platform. So we are planning to understand what are the technology components they are using and how their architecture is different from other platforms. Yeah. So first of all, yesterday I told one thing, which is when we people use internet, we call it as Internet of People. It's like nothing but IOP, Internet of People. When things is wearables, phone, or some home appliances, this all called things. If things use the internet, then we call it as Internet of Things. But if we are using internet for industries for automation, for a smart city, transportation, for machineries, if we use internet for bigger machines to connect and execute some tasks, that term we call like industrial internet of things, because it is all mainly used in the industry. Okay, now the question is, what is the difference in consumer IoT and industrial IoT? Because in industrial IoT, it should be real time, it should be accurate, and it should be actionable immediately. It should happen. Example, one use case I'll tell. In my home, okay, now the temperature went high. Now I want to turn on my AC. So I open the mobile app, click some button, but some technical issue, it takes some more time for the AC to turn on, or some problem is there in the temperature, all those things. It won't affect anything. It basically it won't affect anything. Might be when I so current room temperature is 35 degree, and I put a AC on 25 degree. When I reach to my home, okay, my room temperature is 29 or 30 degree, but still it's okay. I'm okay with that. I can spend extra time for the room temperature to reduce to 25 degree. But the same use cases, if you assume in a nuclear power plant, when the temperature goes like 100 degree or something, we need to turn on the cooler. Okay, so we are using IoT for that purpose. So let us assume the temperature is going more than 100 or 120 degree. There is a delay in the cooler's functionality. Cooler is not yet started. That means in 120 degree, okay, there is a different chemical reaction can happen in the nuclear plant. and that leads to catastrophic effect inside the nuclear power plant. So if we configure 100-degree, the cooler has to turn on. It should happen. There is no option of delay. There is no option of like no some plus or minus 5 to 10-degree adjustment. Like in a home, I'm okay with if it is 30-degree or 25-degree. I'm okay with. But in industry use cases, 100-degree mean 100-degree. Like there is no option of plus or minus thing. So that kind of automation, IoT implementation, we call it less industrial Internet of Things. What and all industry we focus is heavy machines, all the bigger machine manufacturing company, and transportation. Transportation is one of manufacturing automobiles, and smart city, train, metro rail automation, or completely city traffic control automation. This is all called like smart city solution. And basic industry automations, when this task one is completed, start the task two. This kind of a serial automation. And factories mean like spinning mill is a spinning mill. This is all industries now how the spinning mill can be automated using IoT solution. And healthcare, of course, healthcare, connecting all the ICUs and automating all the process when the discharge is done, like the patient surgery is done, the next room, the post patient room should be ready, post surgery room should be ready. So this kind of a complete automation, we call it as a industry automation. Yeah. So in industry, there's a new term we are using that is called digital twins. So digital twins, what is a digital twins? And because whenever you talk about industry automation, we talk about something called digital twins, because you have a very big machineries. Now you need to automate or manipulate that machine. So doing it in a real machine sometimes is harder. See, as a programmer, let us assume I'm a programmer. There is a huge machine. I want to do some validation, data collection on that machine. Go to the physical machine and doing those sensors component and doing trial and error is very complicated. Let us assume a spinning mill industry. In a day, they will, there's a thread, no, they will do more than like 10,000, 50,000 threads they will do in a day. So there is a machineries which is doing 100 to 50,000 threads in a day. Let us assume now I want to do IoT deployment. That means sometimes it's a trial and error. So you have to go and set up, you need to figure out where to set up the sensor, where to do the automation stuff. So it takes at least a month of time to do experimentation and deploy your system. In a spinning mill industry, if you stop their production for a 1 month, that company will be in a huge loss. Okay, they can't afford a 1 month production stop. So this is not only spinning mill. If you take oil and refinery manufacturing, and I want to automate the entire refinery oil and refinery system. So while doing the automation, what I have to do is I need to stop their production, stop their oil refinery entire manufacturing stuff. I need to stop, and I have to manually go and deploy this sensors, everything. So here, see, it is not like a 2 or 3 hour just a deployment. First, I need to deploy, I need to get the data, and I have to analyze that the data are coming properly. So I need to kind of experimentation. It takes minimum a week, at least minimum a week. So during that week, stopping the production is not possible. That's why in industry, we come up with a concept called digital twins. That means if I have a machine which is do the car manufacturing. So when automobile parts are coming, this machine will assemble all the parts and do screws everything. So in a day, it can manufacture 200 cars. So now instead of stopping their production, what I am doing is I'm just taking a digital, the virtual of that particular machine. So one is a physical machine. That's why I say it's a physical machine. I'm computerizing that physical machine, its functionality, everything into the digital software platform. So in this platform, it has a CAD model, real-time operational data model. So I'm just modeling entire physical machine into the digital software platform. Now in this platform, it is a software, purely software. I can attach any sensor. I can see what is the data is coming, and how the data flows are happening. I can do all the experimentation in my digital machine. Once everything is successful, I take 1 hour time just to stop the production and go quickly deploy that sensors in the machine, because I don't need to do any experimentation. I have done all the experimentation in the digital machine. I just cloned that physical machine into the digital form, so I can able to do all this function. I'll show some videos so you get some context of what is this digital twins. This is a very famous term recently used in all the industry IoT things. So you should know what is this digital twin. So here you can find.
Manufacturing machines can be a complex and costly process. Assembling the first prototype from parts that haven't been developed or tested together will often cause problems, and getting everything to function properly may require significant amounts of materials and effort. Nobody wants to be known as the manufacturer of poor and unreliable machinery. So wouldn't it be great if you could build your first prototype, secure in the knowledge that it already has hours of thorough testing behind it? Well then, may we introduce you to Mavea. Mavea combines all plans for your machine into a single virtual model called Digital Twin. This includes all the components necessary to build your machine, such as the interface control system. The digital twin that is created is a virtual physics-based representation of your machine, capable of simulating its behavior and use in real time. The Mavea software simulates real-life physics, so the machine can be tested in different environments and on the actual tasks that it's designed for. You will be able to detect potential problems before anything is even built. The digital twin can be inspected and modified when necessary, and stakeholders can also get involved in the development process at an earlier stage. The rapid development iterations that the digital twin enables will result in fewer prototypes, reduced costs, and faster lead times. Moreover, Mavea's solutions allow operators to use the simulation for training, which means they will be qualified to use the machine before it even exists. The digital twin lives and evolves throughout the life cycle of the product. Once connected, the digital twin can analyze the machine's use and behavior in the field and provide vital feedback. This data can also be used to develop the product further. With Mavea's digital twin software, you can develop even the most intelligent and complex machines with ease and change the way you engineer and operate your products. Read more about Mavea Digital Twin on our website.
So in this video, you might get the basic concept of what is digital twin and why it is really needed. So as I told, see, manufacturing machineries is a very complex process. You need a multiple iteration of the machine. So using this digital twins, you are doing every manufacturing process, testing process in a software, not in the physical machine. So this allows you to a lot of experimentation and quicker prototyping. In the same way, in industrial IoT, when you already have a machine, you deployed the machine. Now, in that machine, we need to add some sensor, like we need to add some motion sensor or some sensor, and we want to understand the behavior. We want to get some data and understand the behavior of the machine. Doing it in a physical machine is a very complicated task. Again, it's a very complicated task. That's why we are doing it in a virtual or digital machine where we can attach any sensor, we can see how the performance, if everything is goes, then we can go to the production and deploy our sensor. So all the industrial Internet of Things platform, you might hear about this word called digital twins. So you can understand what it means. Digital twin means it is a physical one. You just clone it and put it in the software in digital form. So you can do a lot of experimentation with that. Next, we go through about the industry 4.0. First of all, 4.0 mean what is the 3.0? What is the 2.0? That's our question. And this is what it is. We all know from 1990s, all this industry revolution happened from Europe and across the world. Industry revolution happened. So in the first industry 1.1, see, before that, okay, human use either like human use their physical body to do machinery activity. they do themselves. And they may use additionally like cows or horse to do the physical activity, like some mechanical activity if they want. They will do with a cow, horse, like they want to do like agriculture thing. All, see, there is no machine exist before 90s. There's no machine exist, so the human do themselves. Okay. And when Americans are see, a lot of Europeans basically they move to Western country because they are all rich and they don't want to live in the monarchy model with the king, and these all rich people, and they really don't want to live under the king thing. So what they have done, they find a way to move to a different world. That is like they move to the American world. So where there is no king, they are the rulers. So they are there. Now the thing is, they are all like rich people, and they need someone to do agriculture. They need someone to do all the basic stuff. Transportation, basic stuff. They can do themselves. They need someone to do. Till the date, every human, they do agriculture themselves. They do all the missionary activity themselves because that is how the evolution happened. But when these people, rich people, went to the different part of the world, and they find it, there's no one to work under them. Okay, because they are all rich, they have money, but there is no one to work under them. So what they have done is they have done they exported set of slavery people from Africa or other countries to the US, but they could not able to solve their entire problem. That's why they thought of can I use some machine to automate my existing farming, my existing all the basic stuff, what and all I need, can I do machines to automate? That is where the first step of automation comes. See, they have a horse, they have a cow, everything they have, but they don't have a person who can drive it. Okay, because this guy can't drive it. So they need someone can drive the horse. So they can be sit in backside. They need someone can drive it. At that time, they don't find anyone because everyone is rich in the community. Everyone is rich. They don't hire a driver. So that is the biggest challenge they have. So they come up with the alternative thing. Can I use a machine and automation so that I can replicate the human activity? So what at the time they have is a stream. So they will boil the water where the stream will be produced. Using that stream, they can do the mechanical thing. One is like railways. So if they want to transport from one place to another place, they use this water stream. Using that, they build a simple machine. That machine can take them from one place to another place. So the same concept they started using on agriculture and all other industries. They started using this concept where they have a water, they will heat the water, then the steam comes. Using the steam, using hydraulic effect, they could be able to do some mechanical jobs. Okay, instead of a physical one, they use this way of doing a mechanical job. So that time, all the steam engines are very famous. It is used across the industry, not only for transportation, it's used for manufacturing everything. So that is, we call it like industry 1.0. It's powered by water power or water steam. Then now they have used the basic thing they could be able to manufacture. Now they with the steam engine and the heat, their production count is very less. Like they could not able to achieve the larger production count because you have to manually heat the water and use the water to do some functionality. So in the next generation, Industry 2.0, they come up with electricity. So advantage of electricity is you don't need to heat something. You don't need to make a string and then send the stream to the mechanical automation. So instead, people started using electrical power. So you just turn on the machine, the motor can run. So this motor which runs on the steam, now the motor can run with the electricity. So the Industry 2.0 is all about mass production. So they have an assembly line. They can able to do mass production of vehicles, car, like whatever they want with the electricity. So the Industry 2.0 is all about electricity. So the people now moved from water to electricity. So with the help of the electricity, they could able to do mass manufacturing. In Industry 3.0, when people started inventing transistor and people made like a small IC chip, integrated chip, and now people use that electricity, but the people can control the electricity usage. They can use right softwares. the software can control its performance, improve the performance. So the industry 3.0 is all about automated production and computer IT system. Because see, still electricity is there, but someone has to go manually and turn on the switch. When they invented semiconductor, they could able to turn on, turn off the switch in a software. That is the industry 3.0. So the industry 3.0 allow a lot of automation. Okay, we can write various softwares and automate the entire industry. That's all about like industry 3.0. Now the industry 4.0, it's all about IoT, machine learning, and autonomous. See, automation is different from autonomous. In automation, we human has to write the software to do some automation. In autonomous, the machineries can talk to each other. They can talk to each other, understand what they want to do, and they can program themselves. There is no, even though, see, every aspect you can find, they are removing a human from the picture. First, the human has to physically drive someone, like, physical human activity. They use water to automate that one instead of a human activity. Now the machine can do. Then this machine need again there is a human effort of heating the water. This is a human effort is there. Then they want to reduce that human effort, so it's a one button click. Electricity is used to do the mechanical activity. And third, like a human again think like, why I need to turn on, turn off? It should be automated. So they use a software in Industry 3.0 to do complete automation of the thing. Then the fourth evaluation, human is thinking, why I need to write a software? Why can't machine talk themselves and do my job? I just need to tell this is what I want, this many cars I want to produce. The machine can talk to themselves and they can adjust the timing and balancing the schedule. It should be able to manufacture 100 cars in a day. So that is where the industry 4.0, it's all about machine to machine communication and autonomous functionality. It's the autonomous system where the machine can take action themselves. Zero human intervention. It's a zero human intervention. And we are all going to this industry 4.0 thing. One of the applied thing is like a industrial IoT, which allows machine to talk each other and take a decision accordingly. So the next we talk about this IoT use cases. So before that, I will show some video about industry 4.0. See the same thing which I explained now, but if you understand it into a more graphical format, you will get it in a better clarity what it really industry 4.0 means.
It was in these Swiss mountains that the world was first introduced to the phrase the Fourth Industrial Revolution, and it's been a hot topic among academics, politicians, and business leaders ever since. But what exactly does it mean? The term Fourth Industrial Revolution was coined by the founder of the World Economic Forum, a former professor named Klaus Schwab. Schwab wrote a book with that title to describe an era marked by a technological revolution that is blurring the lines between the physical, digital, and biological spheres. Let's break that down. Technologies like artificial intelligence, autonomous vehicles, or the Internet of Things are becoming ingrained in our day-to-day lives and even our bodies. Think of voice-activated virtual assistants, Face ID recognition, or healthcare sensors. Schwab first presented his vision of the Fourth Industrial Revolution at the World Economic Forum's annual meeting here in Davos in 2016. But to understand the idea, we need to go much further back in history, to Industrial Revolution number 1. The first Industrial Revolution started in Great Britain around 1760 and spread to Europe and North America through the early 1800s. It was powered by a major invention, the steam engine. The result? New manufacturing processes, the creation of factories, and a booming textiles industry. From the late 1800s, the Second Industrial Revolution was marked by mass production and new industries like steel, oil, and electricity. The light bulb, telephone, and internal combustion engine were a few of the major inventions of this era. The Third Industrial Revolution, sometimes known as the Digital Revolution, occurred in the second half of the 20th century. In just a few decades, we saw the invention of the semiconductor, personal computer, and the internet. So what separates the fourth industrial revolution from the third? Experts say the difference is that technology is merging more and more with humans' lives, and that technological change is happening faster than ever. Consider this. It took 75 years for 100 million users to adopt the telephone. Instagram signed up 100 million users in just 2 years, while Pokemon Go caught that amount in 1 month. 3D printing is just one example of fast-paced technology in the fourth industrial revolution. The industry has gone from a business idea to big business, with 3D printer shipments expected to increase from just under 200,000 in 2015 to 2.4 million in 2020. Today, you can have a hip replacement from a 3D printed bone or use a 3D printed bionic arm. Talk about blurring the line between humans and technology, right? This new era of technology is driving a lot of innovation. You can see in this chart the number of patents related to the fourth industrial revolution for things like 3D printing or AI has been climbing up and up since early 2000. Organizations are embracing new technologies to make their businesses more efficient, similar to how they embraced the steam engine during the first industrial revolution. But some companies and governments are struggling to keep up with the fast pace of technological change. Research shows innovators, investors, and shareholders benefit the most from innovation. The risk is that the fourth industrial revolution is making inequality, which is already a big issue, even worse. One study found billionaires have driven almost 80% of the 40 main breakthrough innovations over the last 40 years. That's a problem when the richest 1% of households already own nearly half of the world's wealth. Experts warn we are in a winner-takes-all economy, where high-skilled workers are rewarded with high pay and the rest of workers are left out. Studies confirm technologies like AI will eliminate some jobs and create demand for new skills that many workers don't have. Privacy concerns are another issue as the fourth industrial revolution turns every company into a tech company. Industries from food to retail to banking are going digital, and they're collecting a lot more data about their customers along the way. Users are starting to worry that companies know too much about their private digital lives. The World Economic Forum says a majority of leaders don't have confidence their organizations are ready for the changes associated with the fourth industrial revolution. With tech changing fast every day, it's time to catch up. Hey everyone, Elizabeth here in Davos, Switzerland. Be sure to check out our other CNBC Explains videos.
So this gives some context of what I have meant about 1.4, 2.4, 3.14. And 4, she mentioned one important word. Every industry, irrespective of their domain, they should have to become a technology company. There is no option for them. If they are oil company, they think, why I need a technology? But in industry 4.0, they don't have any option to convert them into the technology company. I have a restaurant, I make like a dosa vada. So there is no option for me. I have to get into the digital era. I have to update all my platform into the digital enable. The consumer can reach out me through the digital platform. So every company in future has to be a technology enabled company. That's what this industry 4.0 tells. And the sensors and combination of this software, hardware, and AI machine learning enables that autonomous manufacturing solutions where things can do itself. You just need to instruct it. So the system can execute this task in autonomous way. So next, we are going to explain about the Iot use cases. See, this is my personal use cases, which we worked as a company. We worked in one milk industry where they want to do some basic automation in the industries like very famous milk manufacturing company in Tamilnadu. So they're looking for a IIoT solution where they can automate the basic thing. So the existing thing is a SCADA and PLC based thing. But I told, right, like the difference between IoT and previous generation is, I told yesterday, the CCTV camera. So in a CCTV camera use case, you have a recorded video, but it's not in real time. I have to physically present in the manufacturing facility or in my home to get that video footage. But in Internet of Things, that data can be sent in real time. I can be any part of the world. I still able to monitor my home with this Internet of Things technology. This is the same use cases industry also want. So they have hundreds of milk processing unit across Tamil Nadu. The founder want to manage entire branches, the 100 manufacturing units in a mobile phone. He want to understand at which unit, how many, what is the production in a real time. Right now, how it happens is it happens in a weekly basis, where someone manually enter the data, production data, all those things, and they have a meeting either in a weekly basis or monthly basis. This is called post data. Once the tasks are completed, and after a month, they will review it. Okay, unit number 1, this is the total manufacturing. Unit number 2, this is the total manufacturing we had. If they want to increase the manufacturing capability, right now they don't have any real-time solution. They really don't know why that unit 2 has a lesser production, why the unit 3 has a more production. They don't have any data to analyze this one. There's always a post data. But IoT based solution enable a real-time analysis, and we can monitor all the 100 milk producing unit in a real time using a single mobile app. So that is the use case we are going to see. If you take a milk process automation industry, this has a milk storage tank. We have a different type of tank. Every tank has its own functionality. So I will show one video to understand how it entire system works. Then I will explain how does IoT based solution really help them. So for especially for our customer. Yeah, so I'm playing this video. So this video help you to get a context. What is the problem statement in the milk industry and how milk processing is happening?
The milk goes from the udder through the milking claw and piped immediately to a very large refrigerated bulk tank at the dairy. Milk is warm when it comes out of the cow, about 100 degrees, but is quickly cooled to about 40 degrees in the bulk tank. The milk is loaded each day into a large truck that transports it to a processing plant. Milk is tested for safety and quality before it goes into the truck and again when it arrives at the processing plant. The milk is then pumped from the truck into the processing plant. At the processing plant, milk is pasteurized,
pasteurizada,
and homogenized.
homogeneizada.
The pasteurization process heats the milk to 160 degrees for 16 seconds to keep our milk safe. The milk you drink at school is always pasteurized. At the processing plant, milk is also homogenized. This means milk is forced through small holes to break it into smaller particles. If milk is not homogenized, the cream will separate out and float to the top. Finally, milk is packaged into bottles and cartons or made into other dairy foods you love, such as cheese and yogurt. Boys and girls, what did you learn about processing? The milk is transported, milk you drink at school.
Okay, so here you need to understand. I in the slide I have shown different tanks, right? So when they collect a milk from a cow, the temperature of the milk is 100 degrees Celsius. When they're ready-madely collecting from the cow, it is like 100 degrees Celsius. Now you can't transport this 100 degrees Celsius because 100 degrees Celsius, the problem is it's a good temperature for bacteria to increase. So what they will do is they will reduce the temperature from 100 to 40 degrees Celsius in the collection point. Okay, and then it will be put it on the trucks. So now the temperature of the milk is 40 degrees Celsius. This milk is taken to the industry. Now the milk temperature is 40. The milk will be put it on the tank, which has a 40 degrees Celsius tank. Then the milk will be sent to this another tank, which is a heat tank. So in the heat tank, the milk has to be put it on 160 degrees Celsius so that it will boil enough, like properly it boil. But the condition is it should be maintained only 16 seconds. If it crosses the 16 seconds, you can't use that milk. It means like you already made the milk for a home use. See, when we buy a milk, what we do is we will boil it for more than 100 degree, 150 degrees Celsius for a longer time, not a 60 second, for a longer time. Then we start consuming that milk. If you do 60 seconds, the milk will be protected, and then basically it's a pasteurized, the milk is pasteurized, and we can send the milk for the consumer, and again the consumer can heat the milk. But if you heat the milk for more than 60 seconds, if I heat the milk for 30 seconds, then it is like, this milk is not useful. Like, the milk is, because it's directly drinkable, it is not useful. So the condition is, in the heat tank, it should be in 160 degree, but only for 16 seconds. After that, the milk will go to the cooling section. There is another cooling tank. In the cooling tank, they will reduce the milk temperature to 10 degrees Celsius. That's because it will be in a 10 or 15 to 10 degrees Celsius. That's why when you buy a milk packet, it's always cold, because they maintain the temperature as 10 degrees Celsius. So this rapid temperature high and sudden temperature decreases, this will kill all the bacteria and any other germs in the milk. This is what they do, the pasteurization. Now, the challenge here is the industry, which is a very famous milk industry in Tamil Nadu. So for them, what is the challenge, I tell? Okay, so they put a human resources for everything. So that means when the milk, in the first tank, the milk is in 40 degrees Celsius. So somewhere the pipe, the milk is coming and it is filling the tank. So someone, as a human, has to stand in front of that, and his role is continuously watching that the tank is completely filled. When the milk start overflowing, he will go and stop that inlet. He basically stop that inlet. So the milk don't come here. And this is a very manual task. Someone who has to wait and watch the tank has to fill. But this tank is almost like 15 feet high. So you can't even go top to see it. So what people will do is they simply turn on the switch. Milk is filling. When the milk is coming out, then they'll turn off the switch. So that side itself, they are wasting couple of liters of milk, because they wait until the milk come out from the tank. Then when that is done, they'll keep it for some time, almost like 1 or 2 minutes. They will keep it in this tank. Then again, they will turn on another tank. So the milk will come from this tank to another tank, where this tank is a heat one, where the milk is kept on 160 degrees Celsius. So again, this tank will, they wait for the tank to get filled. So again, the milk will overflow. So they say, okay, the milk is overflowing. They turn off the supply. Okay, now here the milk should be maintained just 16 seconds. So it is that person's responsibility. I ensure that the milk is stored in this tank on 16 seconds. Again, it's a human one. Sometimes they will maintain on 16 seconds. Sometimes they will put it on 30 seconds. Sometimes they will go for a break. They will go for a tea break or something. They don't even care. So here, a lot of milk can be wasted. Okay. Then after this one, the milk has to go to the cooling tank. So here, if you see that they can collect samples for lab testing. So they will ensure that all the bacteria and virus, anything is killed in the milk, all the germs are killed in the milk. So they have to do a sample collection. Some milk they'll collect and go take it to the lab and they'll test it. Then again, that will go to the final tank and they keep it for almost like some 5 to 10 minutes time in this tank in the 10 degrees Celsius temperature. And from there, again, after the 5 to 10 minutes time, the milk will go to the supply, where there's a pockets will be there. They are filling the pockets, and the manufacturing is happening. Like, they manufacture a lot of packet with a different quality, of liter, 1 liter, 2 liter. Okay. Now the owner approached us and told, see, every facility we are losing a huge amount of milk is wasted, and some facility the entire tank has to be dissolved. Sometimes I told one use case, right? When milk comes, they will go for a tea break, so the entire milk has to be discarded. So these are the reason. See, the entrance, when they collect the milk from the cow, if it is 100-liter milk, when all the production happen, everything, they only get it like a 70 liter. The 30 liter will be gone. Okay, and another use case is sometimes this all like a multiple manufacturing facility. So the laborers and the employers, what they will do is the supervisor, what they will do is all the process is completed. Now they got a 90-liter milk, but they still report 70-liter and say 20-liter milk is like it is not useful. But what they will do is they will separate the 20-liter milk and they will sell it externally. They don't so this is like an arrangement between the employees and the supervisor. So what they will do is they will take 20-liter milk every day and then they will sell it in the outside market. Because see, they have a counter for the packet. They know how many packets are made, 1-liter packet, half-liter packet. What they will do is when the milk comes, they will separate it to the different canal and then they sell it outside. So these are all charges for the owner. And 100-liter milk, he will only make 70 or 80-liter milk in a day, and lot of wastage is there. So here, what we have done is we put two sensors in the tank. In the bottom, we placed one sensor. It's a temperature sensor. It's a kind of a small rod. So we placed the rod in the bottom of the tank. Okay, and in the top, we used one ultrasound sensor. See, we put that ultrasound sensors on the top. It is like a knob. You can just connect the knob. In the bottom also, it's like a knob. The temperature sensor will be locked in the tank. Now, what it will do is when the milk comes here, and there's a controller, it's a PLC controller to turn on, turn off. It's a solenoid valve. The valve will turn on and turn off the inlet, the supply. Okay, so this all IoT sensors. Okay. Now, yesterday I explained like we need things. Things is nothing but tank. Sensors we have. Second one we need is a gateway. So we put our intelligent gateway, and then in this gateway has to connect it to the broadband like internet, and from that the data will go to the cloud. This is overall IoT architecture everyone knows. So what we have done, these are the things. The tank is our things. We put totally 3 sensors. One is like a temperature sensor in the bottom, and the ultrasound sensor in the top, and then solenoid valve sensor to turn on, turn off the supply. So in the valve. So 3 sensor we put. Now the sensor data will be sent it to the local gateway. So now the model is when the milk is like poured inside, the solenoid is turned on. So it is waiting for the response from the ultrasound sensor. Ultrasound sensor will say when the milk fill in the tank, completely fill in the tank, it will instruct the gateway, and gateway will send the command to the solenoid saying that, hey, this tank going to be filled, so please turn on. It is exactly till 1 or 2 minutes before. So when it takes an action, the milk will be filled in the entire tank. There is no overflow. That means there is no wastage. So now we know this tank is filled, and we have a small temperature sensor. The temperature sensor can control the thermometer. So there is a temperature section to heat, cool the tank. So it will control that. It will tell, okay, here I need to maintain the milk on 40 degrees Celsius. So the temperature sensor is make sure that the tank is in 40 degrees Celsius. If the tank goes like 45 or something, it can again send the data to the gateway, and gateway can turn on the temperature one, like the heater. Basically, there's a heater, so it will turn on and turn off the heater based on the temperature value. And there is a timer, so we know that this milk should be kept here for like 3 minutes. So once the 3 minutes time is done, this timer again will send it to the gateway. Gateway will turn on another solenoid valve, so the milk will flow from this tank to another tank. Again, the same process. So you can understand how many sensors we are used. We used a temperature sensor. We use the ultrasound UV sensor. We use a solenoid valve as a milk inlet outlet, and there is an on-off sensor. The on-off sensor is to turn on, turn off the heater or cooler. It's an on-off sensor, and then there's a timer. So the timer will maintain that this milk kept on 16 seconds. So the timer will started when the milk will fill in the entire tank. The ultrasound will tell the solenoid, hey, stop. Now I have filled the tank. Now it will inform the heater, hey, please heat this tank. The tank gets heated. The temperature sensor keep on monitoring the temperature. and if a temperature achieves the, basically here it turn on the cooler. So if a temperature achieves the particular 160 degree temperature, then the temperature sensor will tell the heater, hey, you turn off because I have already in 160 degree. And it starts the timer. The timer will kept for the 60 seconds. Once the 60 seconds is over, it will be informed to the second solenoid valve. And the meantime, there is a dedicated sample collection. It's automated. So the sample will be directly sent to the lab facility. In the lab facility, see what they will do is they will basically there is a manually they will check if there is any germs are available. So they will do, and the process is done. Then the final milk will be go to the tank number 3, and it comes for the 10 degree cooler. From that, we will send it to the automation PLC system where the packing is happening for different packages. Now, the owner can simply take a mobile phone and he can select his branch, whichever branch he wants. And in a real time, he can see all this tank and what is the milk condition and how much liter milk is poured inside the tank. So entire processing, because what we do is from the gateway, we send this data to the cloud software. So the data is sent to the cloud. From the cloud, the data will be displayed on the consumer mobile phone. So he can go through the process. He can, if he want to modify some process, that is possible now with this system. And in a real time, he could be able to process, automate, and completely monitor the entire system flow. So this is one of the use cases in milk process automation industry. You can assume the same use cases is for oil refinery, same concept. Oil is taken, multiple tanks it will go, and it will keep on refine in a different tank. So once that process is done, then final petrol or chemicals, whatever they want to extract, they will take it from there. So the entire process can be automated, and then the entire process can be monitored remotely. That is the important use cases of industrial IoT thing. You don't need to be physically present in your manufacturing facility, because most of the manufacturing facilities are in the remote area. By connecting this IIoT based implementation, in a real time, we can monitor all the manufacturing facility. Important thing is we are collecting so much data. The data are collected. So if I want to improve my process, if I want to put another tank and speed up some process, that is possible because you have gathered so much of data and you can understand where the wastage is coming. See, after deploying all those things, might be my production is for 100 liter, I will make 97 liter. That is my production. The 3 liter is somewhere some wastage is there. But I have collected so much data, I could be able to process where the 3 liter is wasted and which tank it get wasted and how I can optimize the 3 liter. So I could be able to increase my productivity from initially it was 70%. With IoT, we can able to get it on 96-97% productivity, and still with the data collection and cloud platform, it allows you to reach the 99 or 100% productivity. This is the use case. I have explained one industry, but you can apply this for as many industry you want, like spinning mill, like a car manufacturing, oil and refinery manufacturing. Any industry if you take, you can apply this model. Next. So I will just remind what and all we have gone through it. So first we studied about what is the difference between Internet of People, Internet of Things, and Internet of Industrial Things, Industrial Internet of Things. So Internet of People is for we people to communicate each other. We use Internet. For Internet of Things, the consumer, like smart bulb, smart refrigerator, all the consumer things to communicate each other, we term it as IoT. Heavy machines, like tanks or sensors in an industry, if it communicates each other, that we will call it as Industrial Internet of Things. That's what initially we studied. The next we understand what is this industrial revolution. We understand what is the industrial 1.0. It's all steam engine. Industrial 2.0 is about electricity. We invented electricity, and The same motor which operated in a steam engine, we converted into the electrical or oil-based motor. And third is software evaluation. So we have done a lot of automation by writing a software code. We automated the manufacturing process. And the fourth is IoT, machine learning, AI. So which helps us to do a lot of autonomous thing and real-time monitoring, and importantly, increasing the productivity. This is what we studied about Industrial 4.0. Then we learned about what is digital twins. So I told in a machinery, manufacturing machineries, all those things, it's doing experimentation in the physical machine is a very expensive task. You might need to stop your production. You have to take like a week off for the entire production to test, deploy any new innovation in the existing machinery. Or if you want to manufacture a machinery, the trial and error takes more time. That's why we have a concept called digital twins. So what we will do in digital twins, we will take the physical machine into the digital software platform, and we could able to do a lot of experimentation in the digital tools. Once everything is done, we could able to deploy the final solution in the physical machine. We gone through that. And next we saw one IIoT use cases. One is like a milk process automation use cases we saw. We defined the problem statement. What is the problem statement in the milk industry? It is about how people are not doing their job at the right time, and how people can fake manipulate the data, and they can sell it in an external market, the milk, produced milk. And for owner has to physically present in every manufacturing facility to monitor and supervise. But with IIoT platform, we could able to do everything in a real time, and we can increase the productivity. Next, what we are going to learn is IIoT. IIoT is platform. What and all platform available for IIoTs? I told there are three main companies. Yesterday talk, I have explained three giants like Amazon, Google, Microsoft, Azure. They are the leader in cloud storage. They are the number one in the cloud storage. But in industrial IoT, there are another three companies. We call it like Siemens, GE, then the third is like Snyder's. These all three companies are a giant in industrial IoT. So you can see the architecture is almost the same. There is no different. You have a things here. The things is not a refrigerator. It's not a air conditioner. It is not a smart bulb. It is the machines. All these machines we call it as things. So we put a sensors in the things, and I told there's a gateway. So the gateway collect all the things, collects the sensor data, and there is a IoT core, IoT cloud platform, where this data will be sent to the cloud for further processing, and various business apps, mobile apps or web apps or analytics tools to visualize the data and take some action on it. So you can see this is almost same architecture. Yesterday what we see, things, gateway, cloud, and a lot of business analytics application. So in an industry thing, only the things is going to be changed. It is not a home consumer electronics. It's all machineries. That's the only major difference in IoT and IIoT. Next, I told about GE. So GE has a platform called Predix. Predix is a very famous GE platform which can monitor your machine, automate all the functionality. So we will see how this Predix platform works. So I show some video. First, we understand where GE is using this industrial internet.
There's a whole new internet at work. Machines communicating with machines, sharing a wealth of data seamlessly, tirelessly, behind the scenes. Forget real time. This is between time. Machines moving industry forward at lightning speeds. Welcome to the industrial internet. Out at sea, a large cargo ship traverses the giant waves, carrying parts destined for a far-off wind farm. Tiny sensors throughout the engine ensure everything is working properly. They report back on propeller performance and power output. Other sensors above deck monitor the ship's precious cargo and confirm its condition and safety. The ship's tracking data determines the destination and arrival time. Everything checks out. The cargo is now traveling securely aboard a hybrid evolution powered freight train. Inside the cabin, the engineer calls up a status report on the entire train. Real-time slows. Between time, a vast universe of data is collected and interpreted. In the blink of an eye, sensors calculate engine temperature, fuel efficiency, speed, weight, and vibration patterns. At the same time, sensors in the track relay the train's location to the network, where information from all other trains comes in. This gives the network the ability to coordinate movement and optimize efficiencies throughout the entire system. And our train remains on schedule. Meanwhile, at a nearby wind farm, a new turbine powers up for the very first time. Within seconds, tens of thousands of data points are analyzed, and the farm controller delivers operating instructions to the turbine, bringing it up to speed with the rest of the farm. Leveraging thousands of hours of stored data, the farm automatically calculates how to increase and decrease individual turbine output. The turbine can tailor the pitch of its blades to capture just the right amount of wind. As the farm responds to the demands of the power grid, it delivers energy as instructed. Next, the grid carries precise amounts of energy to a network of local charging stations. Drivers can charge up and head home. This is the industrial internet. Brilliant machines providing the insights to make better decisions.
So this is some of the use case of how G is using. Then next we will see their platform, which is called Predix. This is their platform. It's same like yesterday we see AWS. It's similar to AWS, but it is their own platform, specially designed for industrial IoT.
My name is Wes Mukai, the CTO, Transportation Digital Solutions. Now, I always get asked two questions. What is a platform as a service? What is Predix? So I thought I'd take a few moments and answer those questions for you. First off, let's think about building walls. So people in my backyard have a nice rectangular backyard, and there's a wall surrounding the backyard. Now, if you look at the wall on the left, you think about it, this is a very intricate wall. Built out of concrete, got a spaghetti-like pattern. You know, this is going to take some special skills to build. And actually, if let's say the wall broke or I had to fix it, I don't think I could do that myself. It would probably take some special skills. Now, if I contrast that to a wall built in Legos, you know, let's assume it's the same strength, but it's going to have a more structured pattern. You know what? I don't need to use special skills. I can use childlike skills to build a wall. If something breaks, I think I can figure out how to take it apart, put it back together again. So it may take longer, but it takes less skills to build it. Now let's think about those walls in terms of software. First, let's look at the concrete wall. So I can think about all the different layers in this intricate wall as being different layers of software. Top layer could be an application. Middle layer could be database, piece of middleware, like an enterprise service bus. And all the different shades and colors, you can think of those as being different types of languages, like Java, etc. So if I think of Legos as software code, I can think of each Lego brick as a service or a microservice. It's a self-contained program. It could be an application, it could be a database, it could be a piece of middleware. And I can think of each color as different colored Lego blocks being different languages, be written in Java, it's red, say blue would be Python, or it could be Golang. And I could have each block be a self-contained microservice. So now if I want to build, deploy an application using these Lego bricks or microservices, let's say I could take them all and magically throw them in top of a machine. I'm going to call it magic, platform as a service machine. Now in that platform as a service machine, there could be some software underneath there to prepare and run some of the software programs. There's actually some hardware underneath there. But I would take all these different color-coded applications or microservices, I could throw them into the top of this machine. And then you know what would come out the other side would be a fully formed wall or an application. And actually underneath in the dotted lines, you see, I don't really see the hardware. It's actually hidden. Now, I would only interact with this application through a management interface. So the magical PaaS machine assembles all these Lego blocks together and builds that application on wall for me. But let's say if I want to change something. Let's say I have a wall that's fully formed, but you know what, the light green brick, I'd really want to have a dark green brick in there instead. All I'd have to do is get my developer to program a new green brick. They would throw that one microservice into the platform as a service machine, and magically out the other side, the new brick would be installed into the wall. And it's not like I have to coordinate with all the other developers. I don't need to coordinate with some other service owner to lift the block up and put my block in. You can do it in a nice self-contained automated fashion. So what is Predix? Predix is GE's cloud-based platform for the industrial internet, but this is really our platform as a service. So if you think about it, if Predix is what we show at the bottom in terms of the cloud and applications, all the different elements on the top we just explained really are the key components of what makes up Predix. You have microservices, which are these different colored bricks. You have a PaaS machine where I can assemble and deploy these applications in an automated and easy fashion. So I just want to take a few moments and answer those two questions. What is a platform as a service and what is Predix? And hopefully you have a better understanding.
Yeah. So I basically explain what he explained about Predix. See, in the cloud architecture, we call something. There are three terms we usually call, which is called platform as a service, and infrastructure as a service, and third is software as a service. So infrastructure as a service mean Amazon or Google, they will give their virtual machines as basically their Google infrastructure in the cloud. So I can install the computer, I can install the software in it, everything. So I only need their infrastructure and I can do whatever software, hardware I want, I can completely do myself. So that is called infrastructure as a service. In a platform as a service mean already this company will have a computer and they have installed the operating system and they have installed all the necessary software to run the operating system. So it's all already done. Now I just need to run my application on top of it. Okay, so that is called platform as a service. So here this GE thing is nothing but it's a platform as a service where basic stuff and all ready, the computer ready, operating system ready, and the basic software to run the operating system and all those things is ready. Now I just need to install my own software. That's it. This is called platform as a service. The third one is called SaaS. It's called software as a service. We can assume Gmail is a software as a service because the operating system is there, the software to run the operating system is there, and there is an application called Gmail. Okay, so as a user, I don't need to install anything in that. If I want to send a mail, I just open a Gmail, compose the mail, send it to my user. So this is called software as a service. So I don't need to write any single line of software. But in a platform, I need to deploy my own software because the platform is ready. Now I have to play on the platform. I have to deploy my own software. In IaaS, like in infrastructure, nothing is there. Only the hardware machines are ready. I need to install computer, everything I need to do themselves. So the top, what he explained is this Predix is nothing but a platform as a service. But good thing is whatever industry use cases they want, they already build a plugin and component. I just need to do drag and drop and use for my industry use cases. That's the advantage of GE's Predix. And second is another company I told, Schneider. Schneider has a Echo Texture platform. The same edge control apps, data center, the industries grid. So these are the common platform they have. They use it for various machines, plant, power grid, data centers, and building automation, and for various things they are using Echo Texture as the platform. If you want, we can see some video with this. Just to understand what is this Schneider Echo Texture. See, I have explained, but just to give some visual thing, what is this one? This is a simple video.
Hello, my name is John Krajewski. I am the director for HMI SCADA portfolio at Schneider Electric Software. Here we are at the Hanover Fair, launching the 2017 version of System Platform, powered by Wonderware. System Platform delivers connectivity to the widest range of devices, equipment, and an ever-expanding set of advanced applications. This makes it the only complete industrial automation platform in the world. This also enables it to cover virtually any need for any industry. We at Schneider Electric, the world's leading supplier of human-machine interface software, understand the challenges that our customers are facing these days. The massive amount of data coming from all connected devices within the Internet of Things. People are increasingly mobile at work. Companies store and manage their production data in the cloud. Information technologies and operation technologies are converging, and Industry 4.0 sets the new standards. It requires a fresh approach to industrial operation systems and a sound mechanism to build and maintain those systems. That's why we are proud to introduce the world's first operations management interface, the OMI. With this 2017 release of System Platform, any industrial process can achieve world-class situational awareness in real time. You have complete access to all information in your business to empower your teams. They can now make decisions that will improve your safety, efficiency, and profitability using virtually any device.
So basically, this is, as I told, it's a software platform. He has demonstrated with the various apps running. So I can have a simple tablet. The supervisor, he don't need to go to the individual machine to find what is the performance. He just need to carry a simple tablet, and he can analyze all the machineries and it functions. If there is any drawback, any malfunction is happening, everything through this platform. So these platforms are designed so that as a manufacturer, I really don't need to hire a developer to build technology for me. So these are the ready-made solution. I can deploy the IIoT sensors and use this platform to start automating it and monitoring on the real time. Yeah. So I hope we covered all these fundamental things in the session. First, we talk about the basics, Industry 4.0. and milk automation industries for the use cases, and two platform we covered, and you can study about the Siemens also. It's also same. See, the architecture is same. Architecture, there's no different. Its architecture is same, but the platforms, every company build their own type of platform. And hope you got some basic understanding of how this industrial IoT works and what and all its use case. You learn about digital twins. That's a very new term. And how 3D printing technology and all changed. It's a separate another term because a lot of machineries now, the cars can be built with the software and click one button. Like how we print a photos in a paper, people are printing houses in using 3D printer, and automobiles using 3D printer. So this is a very interesting field, and it has a lot of open opportunity for innovation. Because industry, compared to the consumer electronics, industrial electronics is a high revenue generation platform. That's why companies are very excited about industrial automation. Increasing 1% productivity will be resulting millions of dollars profit. That's why technology companies are innovating a lot of things on this IIoT. Yeah, and thank you so much. If you have any questions, feel free to.
Participants, if you have any queries, you can ask now.
Hello, sir. Good afternoon, sir. Hello. Can you hear me, sir? Hello, sir.
Senthil Kumar, sir. Sir, you're muted your audio.
Hello. Hello, sir. It is audible.
Yes, sir. Yes, sir. It's audible.
Yeah. Good afternoon, sir. Myself, Shri.M.Senthil from Sri Institute of Polytechnic College, Coimbatore.
Okay.
Yeah, your session was really wonderful, sir, because the real-time implementation examples were very interesting to hear.
Thank you,
I
sir.
have one doubt, sir.
Yeah.
What about accuracy in IoT, sir?
Sir, basically we are using a standard sensors only. Okay, so the accuracy will be higher. There is no problem. But if there is any malfunction in the accuracy, that's where the software come into the picture. Okay, let us assume like any machine, if any sensor is throwing up inaccurate data, we have a software to compare and we can able to improve or identify, hey, this machine number X, the sensor in the machine number X has some inaccurate data is coming. So we connecting both the software and hardware, so we could able to ensure that the accuracy is always higher.
Okay, sir. I have another doubt. I implemented a practical concept about soil status monitoring, sir.
Okay.
Regarding that, I had a doubt that either it is available to apply the same thing for the different kinds of soil. For example, wet soil, alluvial soil, as like that, it can be applicable.
Yes, sir, it's applicable. See, basically, you are just changing the sensor only, but the architecture is same. The same gateway, same cloud, and an analytics tool. Only the sensor will going to change. Instead of temperature sensor, you are replacing with a soil sensor. So the architecture will be same, sir. You can add any number of sensor in the thin side.
Okay, sir. Which API is best suited for IoT, sir? Either free or paid.
Okay, sorry, have you ever used any cloud platform before?
UBA sir.
Okay, so there is something called Things Networks. Things Networks provides MQTT services.
Can you tell me?
Things,
THINGS.
Yes, sir, Things Networks. Yeah.
Okay.
Yeah, this is a very famous DIY platform.
Okay, sir.
And yesterday I have explained about if you are going for a production quality one, this is all for prototyping purpose. Like if you want to do some prototyping, you can do with one device, two device. But if you are going for production quality one, you can use Amazon or Google platforms, IoT platform, to do this automation, all the data collection process.
Okay, sir. Thanks a lot, sir.
Yeah, thank you.
Senthil sir.
Hello.
Hello.
Sorry.
Senthil sir, your session were all the two sessions were very interesting, and we have never heard about the term about digital pins and many things. So you have taught so very well. Really, it was interesting and very useful and very informative, sir.
Thank you, ma'am.
Really, you have got so much experience in industries. Thank you. Thank you for sharing your all the field projects. Thank you so much.
Thank you so much, ma'am. Thank you. Okay.
I think we have no more queries, sir.
Okay, ma'am. Okay. Thanks, ma'am. Thanks for this opportunity. And I have shared my email ID. Any queries like I can send. And if I get the feedback for the two session, that also helpful to me, ma'am. I can send the feedbacks, participant feedbacks.
Yeah, sure.
Thank you.
Actually, sir, after that completion of all the 5 days program, we will be uploading on feedback links, sir. We'll be send that feedback link to that individual speakers also.
Sure, ma'am. That will be helpful.
Yeah, sure, sir.
Thank you. Thanks so much.
So can you please mail that PPTs?
Yeah, this two PPT I will send it to you.
Yeah, sure. Thank you, sir.
Thanks a lot.
Thank you, Shri.M.Senthil Kumar, sir. So, in spite of your busy schedule, being a founder of JioVio Healthcare, you're spending your valuable time with us, sharing your technical knowledge relevant to social importance. Thank you, sir. Thank you so much.
Thank you so much.
Yeah. Once again, I thank all the fellow participants for your patient listening. I request all the participants to fill the attendance link and then you can leave the session. Thank you. Afternoon session will be on 2 p.m. You just join 10 minutes before the starting of the session. Thank you, everyone.